to the ScalaUA conference.
Thanks a lot for staying here so late. I understand that my talk is the last for today. So definitely I will try to be brief, so that you can finally go home or socialize, whatever. Anyway, thanks a lot to introductions from Matthias and Alexander. They talked about ScalaMeta a little bit, and now I'll be able to do a really specialized talk. So what I'm going to talk today is some really cutting-edge research in our project. So our project is fairly old, I would say, especially by academic standards. It's almost 3 years. And this stuff has been developed in the last few months. So this is hopefully going to be very interesting. So semantic API and ScalaMeta, how do they work together? What's that? Well, first of all, what is ScalaMeta? I realized that that has been discussed today a couple times. So I'll present my own version, and then we'll compare the notes. Well, first of all, ScalaMeta is a research. It was part of my PhD dissertation, which I defended a couple of weeks ago. So, if you're interested, thank you. So, if you're interested in details, there's a write-up. You can, Google my last name and type dissertation, so you'll find a link. So it's a huge document. 240 pages. I definitely had a lot of fun writing it. But in all seriousness, some of the concepts that were brought up today, for instance, the architecture of the Scala compiler, what's this cake pattern stuff, and why this architecture promotes global state, please take a look. There's this chapter 3 called Scala Reflect, which explains how we designed the current de facto standard in metaprogramming and how to release the compiler internals. So to the best knowledge, this is the only write-up about the architecture of the compiler with this level of detail. I mean, when I was writing my thesis, I was like, oh my god, so I don't want to write this, please don't make me do that, but I just didn't find anything to copy-paste or, to reference to, so I had to do that. I think this may be interesting if you're into compilers. Anyway, enough self-promotion. Let's move on to ScalaMeta. So, ScalaMeta is not only research, but it's also endorsed by the creator of Scala himself. So this is the screenshot of the tweet from the last year's Scala days, where Martin said that in one of the future releases of Scala, he considers adding ScalaMeta, and namely macros, next generation macros, which are based on ScalaMeta. So that's one level of endorsement, right? Now it's actually funded. So, as you have seen from my first slide, there was a Twitter bird there, and it's not coincidental. I actually work for Twitter, and together with the engineering effectiveness team, which does developer tooling, we were building next generation internal code analysis tools. So this is something that I will present very, very soon, about 2 weeks from now, in Chicago at Scala Days. Actually, at 13:20, if this makes a difference. So that's another thing. And finally, we're also in partnership with this new organization called Scala Center. There's a guy who's hired there, Olaf. He's the author of Scala FMT and ScalaFix, the tools that were mentioned today. And his recent projects, which is funded by GFL, the Scala Center, whose department Scala Center is also based on ScalaMeta. So basically, ScalaMeta is started as a research project, but it was based on our experience with Scala Reflect, which is a very, very practical thing. And at the moment, so it was built to be state-of-the-art. And it turned out that our ideas were successful. So there are big investments in the technology, big for research thing, and we're rapidly moving forward. So ScalaMeta is actually an active open source project. If you take a look, it has several thousands commits. So as I said, it's pretty active, and the history is pretty big. And the community itself is very vibrant. So we have 5 active maintainers. You can also visit our GitHub channel, where you can get answers to your questions fairly rapidly. Alright, enough with the introduction. Let's talk about APIs that we expose in the ScalaMeta library. So during one of the talks, we heard that ScalaMeta supposedly provides a better API in comparison with ScalaReflect. So what does this amount to? First of all, Matthias, thanks a lot for your kind words. Now let's see a little bit practice. So the APIs in ScalaMeta, they are split into two categories. Something that they call syntactic APIs and semantic APIs. So the latter are the topic of our today's talk, and now we'll briefly cover the syntactic API. So what this amounts to is basically parsing, investigating the structure of the code, so that you can see what the code, what identifiers are there, what definitions, and so on and so forth. And finally, tokens. So let's go through all this, which is covered on this slide. So first of all, for those who have already worked with the Scala compiler, with ScalaReflect, you probably notice extreme lack of ceremony. So the only thing that we need to do here to get started is import ScalaMeta._. So you don't need to create any globals, any reporters, configs, all that is gone. And on the second line in the REPL printout, you just say you take a string, or you can pass a file, or whatever is convertible to a string via our type class, and then you call an extension method parse. And in the type argument of this extension method, you specify the end result. So here we want to parse the string as a term. You can also say that it's supposed to be a type, a pattern, the entire source, a definition. So there's a bunch of options. And finally, we get a monad that represents the result, so either a success or a failure with an error message. And here we just do .get for the purposes of the presentation. But please don't do this at home. .get is evil. Well, you all know that. Anyway, so now, as I promised, after we parse things, we can inspect their structure. So there's a handy method called .structure, which prints out the structure of case classes that comprise the AST in a pretty printed format. So unfortunately, it does not, it does not format the results. So here I had to tweak the output so that it fits the slide, but you can get an idea. So basically, our AST is just, your grandfather's AST. It contains the information about all the features of Scala. So you can see that the application of println is surprisingly represented by a node called apply. Then a name is a name, and so on and so forth. What's really new and cool here is that we also associate tokens with abstract syntax trees. And tokens, they're something interesting, something that hasn't been available in a public metaprogramming library in Scala before. So, as you can see from the final line of the printout, tokens is basically a collection of some entities which represent atomic parts of Scala syntax. So here we can see that println, an atomic identifier, it's a single token. Then you have punctuation, like parentheses, commas, literals, so on and so forth. So what's useful about these tokens? It's not easy to see on this particular example, but the cool thing is that if you write any formatting, if you write comments in your code, tokens capture all that. And that's another very cool difference with what's provided by the current standard ScalaReflect. As explained by Matthias, ScalaReflect is founded in compiler internals, and the compiler honestly doesn't care about formatting, about your comments, these seemingly minor details. So it doesn't matter when you emit code, but it does matter when you write developer tools. And that's why ScalaReflect is unfortunately inadequate for this task. And ScalaMeta, from day one, it was built to accommodate new use cases. We'll talk about them a little bit later. So that's all about the syntactic API. We have more docs in our tutorial, scalameta.org/tutorial. But today's talk is going to be really about the semantics, because this is something new. And well, I can talk about this stuff for hours. You wouldn't like to do that, at least not at this time of day. Anyway, semantic API, what's that? Concretely, we are going to answer the following three questions with this API. That's what I would like to do. That's what I would like to provide the users. So first of all, I would like to be able to take names in Scala programs and then say what they resolve to, what they mean, fully qualified names, for instance. The second question is about types. So just like in an IDE, just like in IntelliJ, I would like to virtually select an AST and then ask what the type is. That's a very useful but a very non-trivial question. And finally, desugaring is something that Matthias brought up before. We will see an example of what it is. So now, time for examples, as I promised. So speaking of names, concretely, if we take this print line of list thing that we've seen before, we would like to learn, using the semantic API, that print line is actually comes from predef, and predef comes from Scala, from the standard Scala package. And the list is actually an alias in the Scala package object. So information like that. That's one aspect of the semantic API. Now types. So here it's much more list of something that desugars to list.apply. And also apply is a generic method, which means that if the type argument is not specified in an invocation of such method, then the compiler will infer that, we'll kind of guess it. So list.apply in turn it desugars to list.apply of int, blah blah blah. And what's interesting about the Scala compiler, and what's also very tricky and I would say maddening at times, right, is that it takes your code that you wrote yourself and then it transforms it into the form that's well understandable only by compiler authors. So instead of list of 1 to 3, you will see list.apply of int of blah blah blah. There's also a var transformation there. So it's pretty insane if you think about it, because when you're writing tools, you want to work with the code as it's written, and all that you have is this stuff. So that's hard, and that's also what we want to tackle. Alright, so we see the three questions that we need to answer in order to write semantic tools with ScalaMeta. So it's actually been on our roadmap for 2 years straight. What do we have to show for ourselves? Well, actually, the story is not that simple. Well, we did a lot of research and figured out that if we just use Scala compiler internals and, well, kind of deal with it, we can write useful tools. But it's hard. As I mentioned, there are desugarings, there's also other stuff. The goal of ScalaMeta, when we started the project, was to decouple metaprogramming toolkits from compiler internals, so that you can use the same API from Scala C, from IntelliJ, and from the new and upcoming Dotty compiler, which is a rewrite of Scala C. But well, what we figured is that it's super hard. So as mentioned here, I think it really takes person years to answer these three questions robustly and portably. And after you implement it, you actually have to maintain it, which is, yeah, you only learn that after you implement. Obviously, a very, very obvious engineering thing, but we need to take this into account. And as a result, well, we actually made 3 attempts at implementing the semantic API. So this one is the third one, and I believe it'll succeed, or I don't know, I just give up. So our new strategy is, well, again, driven by common sense. We want to start with something very simple. We want to answer just the first question. What do names mean in the programs? And then we want to ship this. Afterwards, we want to ship other parts, and so on and so forth, so that we can actually gauge interest from the tooling community and from macro writers in particular, and then see whether we need to solve this huge complicated problem of answering these 3 questions. Or we can answer, I don't know, 2.5 and then disregard everything, do something else, something fun. And another thing, also something that we learned very, very hard way, is that the implementation, it actually must be simple. If it's not simple, then it's hard to implement, and then it's hard to maintain, and it blows up. But just to comfort you guys, so it may seem that our goals now, they're quite different from the goals 3 years ago when we started the project. Well, it's not like that. So portability, that is the ability to write meta programs that target all the platforms in the Scala ecosystem. So as I mentioned, Scala, Dotty, IntelliJ, also Scala IDE. We still need to do that. So I believe that compiler internals are a no-go. That's my personal vision, and I will give it up only over my dead body. So let's see what we do in that vein, how we implement this. So in this talk, we'll try to see how do we give meaning to these highlighted parts. So how do we figure out that print line comes from predef and list? comes from the Scala package object. Actually, we have a fancy technology and a fun buzzword, which is called a semantic database. So in order to answer this question, we actually build a semantic database and then we look up the information that is stored there. So in particular, a semantic database is this semantic DB file. Well, the name is really tentative. Maybe we will split it into bunches of files. Who knows? But what's really important is that it is produced by the compiler, namely by our compiler plugin, and then it lives next to the class files. So here, for those of you who are familiar with SBT, you can see the typical project structure, with SRC and target and Scala -212. And then next to class files, there's the semantic DB. And as a result, if you want, you can package it into a jar. You can publish it on Maven so that people and tools, most importantly, have easier time inspecting your code. So finally, this example it demonstrates how we generate the semantic DB thing for the project called Finagle. This is a library that we developed at Twitter. Well, since I work at Twitter, that's no coincidence. So now, after we discussed what this thing is, let's see how we can produce it and what is there. Well, let's start with a very, very simple example. Again, we see our print line of a list of 1 to 3. It lives in a small object called library, and now let's compile it. So as I promised, we just take a compiler plugin called ScalaHost. Of course, this command line shenanigans, they're absolutely unnecessary because we have a stable version of ScalaMeta that supports this, and you can use your favorite build tool to automate all that. But for the purposes of this demo, we provide the X plugin option to the Scala compiler, and then as a result, next to the usual class files, we actually see the semantic DB thing. And now on the next slide, finally we do cat and then see what's in there. So at the moment, this is the text-based rendering of the semantic DB. Now we have protobuf implementation for this to save space because, well, Finagle is not a really big project. And 5 megabytes of stuff for not a very big project is not good. But again, for the purposes of the presentation, let's see the textual contents. As you can see, the first line, it says that the info was produced from the library.scala file. And then for every name in that file, we actually resolve it. So we say that, for instance, library, maybe you remember that the object was called library. The identifier, it was written from the offset 7 until the offset 14, and it means empty.library, which actually, where empty signifies the empty package, as described in Scala specification. Everything that you write outside of any package, it implicitly goes there. And so on and so forth. Actually, you can see how we represent methods. There we specify their JVM signatures, because this is how Scala specification distinguishes overloaded methods. Then you can see, well, basically fully qualified names. I will not go into exact details. They're specified elsewhere, but they kind of make sense, right? So, for instance, you can see array. The fully qualified name says root.scala.array, which effectively means that array is declared in the Scala package. So there's a little bit more details. For instance, the args reference. It's actually a fully qualified name that goes through the method. So we can see that args, it actually belongs to a method called main with the signature. But, well, again, the bottom line is that for every name in the file, the semantic database, it contains some sort of a unique identifier that we can later use in tools to write refactorings, for instance. If we use this kind of class, if we call this method in this kind of class, then please rewrite this piece of code into something else. So that's one of the goals for the semantic DB. Other useful properties, they include the following, as written on the slide. So first of all, what I find to be a really killer feature about semantic DB is that they are portable, which means that this format, as we've seen here, it's not tied to any compiler internals. So as you can see, it's just plain text. It does not refer to Scala, C, or to DOSI or to IntelliJ. So, however this semantic DB was produced, it will actually be independent of the compiler. So that, for instance, we can write a tool that takes a library compiled with DOSI and then rewrites it for use in Scala, or vice versa. So this is the way how ScalaFix is operating right now. Once we shipped semantic API for ScalaMeta, which is based on this technology. ScalaFix obviously jumped the train very, very quickly. So that's a really, really important feature, portability. Secondly, since the format is portable, we can actually serialize it. We can ship it to Maven or wherever into an internal corporate repository, so that tools can have easier time analyzing code. So the tools, they don't have to be tied to the Scala compiler. Because typically how this works right now, if you want to write a tool that uses semantic information about Scala code, you basically write a compiler plugin, and then as part of your build step, maybe you write an SBT plugin to accompany that. You actually do your job, maybe in an additional phase of the Scala compiler. But that's really hard, and that also involves recompiling the same code again and again if you want to invoke a tool multiple times. With the semantic DB, these two steps, they're decoupled. First, you produce some stable information, just like this, nothing extra, so no compiler internals, as I mentioned. And then you can use tools, maybe on a different machine, or on a cluster, wherever really, to analyze these files. And that brings me to my final point. So the semantic database is also distributable. So you can take, let's imagine you have library2.scala, and you have a semantic DB file for that as well, so you can merge them, or you can split them. Basically, map reduce stuff. And I find this pretty useful. And again, at Twitter, our code base is pretty huge, millions of lines of code. So this is especially relevant for us. But just to sum it up, the semantic DB technology, even though it looks very, very simple, it's actually pretty cool, and it's a big know-how in our community. Because it's the first attempt at a unified format that's independent of a particular compiler that produces it. And I think thanks to its properties, it can be effectively distributed. And I mentioned my upcoming Scala Days talk in Chicago and also in Copenhagen. We hopefully will be able to report our internal results of the work that we do at Twitter to utilize semantic DB and ScalaMeta semantic API in general. All right, speaking of API, so now we've seen the technology that enables all that. So there's also a higher level layer that makes, so obviously you can just take the semantic DB and use this information to do stuff. And that's what our early adopters do. It's really crazy when you do cool things, people just jump there and start using them in really unexpected manner. But anyway, here's our take on how the semantic DB technology can be used. So in ScalaMeta, along with the DB, we also introduced a trait called mirror. So this is something pretty simple at the moment, and it corresponds to our vision of shipping small things at small steps, so that we can develop this faster. And at the moment, the functionality provided by mirror is pretty modest. So first of all, it exposes a dialect, which is basically a version of Scala. So there are dialects for Scala 2.11 to 12, for DOSI, for SBT. All kinds of variations of Scala syntax. Then we have a list of sources that comprise the program that we're analyzing. So for this compilation that involves library.scala, it will be just one source file. And source is basically a ScalaMeta ST, the Syntactic API. And finally, we have the semantic database, something that we've seen before. And the last thing is the promised high-level wrapper. It's a method called symbol, which takes an arbitrary reference, for instance, print line or list, our print line of list of 1 to 3 example, and returns a symbol, which is again a high-level wrapper over a fully qualified name. And as a result, you can have two alternatives. You can either use the semantic DB directly in the third line, or you can use a higher-level API. Whatever you prefer and whatever is enough for your tasks. Speaking of mirrors, here's a very simple example of how you can call these APIs. So basically you create a mirror from a class path, because as you remember, the semantic database is stored next to class files, and the source path, which is well, essentially the files that is provided to the Scala compiler invocation. And after you've done all that, you can do the low-level style, you can do the high-level style, so it's all up to you. Really, really thin layer of logic over the foundational technology of the semantic DB. Also, there are multiple ways to create a mirror. We've seen how to create it using compilation artifacts. There's also integration with SBT, because well, in SBT you can fetch all these paths automatically. This is covered in our SBT semantic example project. And finally, for those who really like danger, you can take an instance of the running compiler, something of type Scala tools and SC global, and well, basically do the same that SBT integration would do for you. Alright, as I promised, that's going to be fairly quick. And now I'll just briefly mention our future work. What can we build based on this new API? Well, first of all, as I mentioned, the goal of ScalaMeta was to enable next generation developer tools. So something that Scala Reflect was struggling to achieve, we would like to address with ScalaMeta. And the semantic API, it finally completes a big gap in the functionality provided by ScalaMeta. Hopefully, thanks to the semantic API, we'll be able to provide an analog of def macros based on ScalaMeta completely that avoids Scala Reflect. There's also this ScalaFix project that's been mentioned so many times today that basically defer to previous presentations, called ScalaFix, and also some ideas for the future. Maybe some of them we'll cover in later presentations. Well, I want to give more talks, so leave something to me in the future. I think with the semantic DB, it'll be easier to build code browsers that are based on something better than grep or C tags. Basically, if you have a semantic DB, you can hook this into your favorite editor and then have command click or control click, whatever you prefer. And also, the improvements that are brought by the new technology, they're not limited to just code browsing, right? You can imagine how this integrates into code reviews, which typically don't have hyperlinks in very, very rare cases, and so on and so forth. The second big direction for development is actually improving the semantic API. So, as I said, we start very, very modestly, and those of you who are familiar with Scala Reflect, you definitely see the gaps, right? So, how do you enumerate members? How do you figure out signatures of symbols, and so on and so forth? Of course, we want to improve that. So, as mentioned on the slide, on our issue tracker, we actually have a plan how we achieve this. And finally, we don't want to stop on just fully qualified names. So another step would be to enrich semantic database with additional information. For instance, types of terms, the second question. Maybe desugarings, this is the third question, but only if they're actually needed to people. If this is just an academic exercise, well, I am not an academia anymore, so I'm not interested in that kind of stuff. And finally, this is Olaf's idea. Olaf and I will collaborate very closely on this whole ScalaMeta project. We can even include custom information that's interesting for tools. So for instance, for Olaf, it's interesting to see which imports are unused. This is something that's quite complicated to see even from compiler internals. And we can compute that for you in our compiler plugin and store it in the semantic DB so that linters can do a better job and can have easier time reporting errors. This is something that we're actively exploring right now. Right, just to sum it up, what we've heard today. So there's a stable release of ScalaMeta which ships with the first version of the semantic API. It's an experimental module, so don't expect that level of stability and actually non-bugginess that we have in this syntactic API at the moment. So, as I mentioned multiple times, we start really modest, so the only high-level API is resolving names via graph.symbol. But this year we plan to ship more functionality, including type resolution, type inference. We'll see how it goes, how we prioritize this. And all that is underpinned by semantic databases. I think it's a pretty important technology, and it will enable new kind of tools by itself, even without the high-level APIs. So alright, let's keep in touch. And if you're interested in metaprogramming, if you're interested in compiler development and tools, take a look at our repo, and we would really like you to compile your projects with the Scala Host plugin. So as mentioned in the repository, the SBT integration is pretty trivial. Basically specify our compiler, our SBT plugin, and it does all the configuration by itself. If you run into any bugs, please let us know, we will patch them. And to learn more, drop by at Gitter, take a look at our talks at Scala Days and also at FlatMap. Olaf will be giving a talk at ScalaFix. He's also a very important contact person for our project. So please reach out to us, we will be very, very happy to collaborate. Thanks a lot for your time. Alright, I think we have time for a few questions. Alexander has a question. Can we give him a mic?
Is it thought of supporting different versions of semantic database? Because there are going to be features added into a language, like, I don't know, implicit types or whatever. How is it going to be mirrored in a semantic database?
Alright, that's a great question. So obviously it's hard to predict the future, but we do our best to accommodate it. Well, first of all, we have dialects, which basically specify a language version, and the semantic database is going to include the dialect. That's one thing, so that you can distinguish compilations produced by different versions of the compiler. And the second thing is that, well, obviously semantic DB, the central to it is a data schema, and data schema evolution is a known complex problem. So for now, we plan to use protobuf, and we plan to format data payloads. So the text printout that you've seen is just a prototype, it's just debug information. So I think that the combination of an explicit thing called dialect, which reifies differences between Scala implementations, and the version number and rigorous versioning scheme for a protobuf thing, I think it makes us future-proof. We will see in the future whether it's correct. All right. Please go ahead. Over here.
I don't use that tool in my work, but I just want to know, what about implicits? Is it implemented in the current version, or do you have some plans in the future? Could you say a few words about that?
Yeah, of course. That's a very good question. So if we just go back to the sugarings, well, basically implicits, they count as the sugarings in the Scala compiler, because this is something that you don't write and the compiler inserts for you. So at the moment, this prototype does not support these kind of things. But obviously for tool writers, it's very important. For instance, what if you're writing a tool that, I don't know, figures out what code is unused? So maybe your implicits will be marked as unused, even though, well, because you don't write them explicitly. Of course, this is something that we want to add to the semantic database. So probably if we just, scroll to this printout, we can imagine that we will have another section. In addition to symbols, we will have a section which says implicits, and it says, at this position, we have inserted an implicit which looks like this. And maybe we'll have a symbol that represents, a fully qualified name of that implicit. And if that implicit involves other implicits, well, you get the idea. It's all implicits all the way down. So the short answer, yes, we plan to support this, but the V1 of the semantic API doesn't. Okay, anything else? Guys.
Alright, as a compiler geek myself, I'm very excited by the compilers, and naturally that's probably the single most important tool in the Scala community. So in that department, we have several exciting developments. First of all, there's ongoing hacking on the new Scala compiler, .t, which is developed by my former lab. It's been in development for several years, and so far it's looking so awesome. The thing is that over the 10 years of evolution of Scala, Scala has got well, some deprecated features and some experiments, they haven't worked so well. So in Dotty, in the next big version, Scala is getting cleaned up. It's getting a new calculus, a new type system, and more exciting features like implicit function types or union types are added. So I think this is a pretty big development, and it would be a good idea to stay in touch on Gitter at lamppfl/Dotty, and stay tuned, watch talks by Martin Endersky and his students at Scala Days. Also, speaking of another Scala compiler, Scala2, a lot of work, a lot of effort has been put by Lightband, the current commercial maintainers of the compiler, into improving the performance of Scala. Just recently, several weeks ago, Jason Zaug, one of the developers from Lightband, reported significant performance improvements to the Scala compiler. I think this is also a very, very interesting trend that shows that Scala every year it becomes lighter, easier to understand, and of course faster. So I think that this year will bring significant results in these areas.